Section 1.2 continues with the topic of similar triangles. The sum of the measure of the angles of a triangle, of course, equals 180 degrees. So looking at this first example, we find that 48 degrees plus the 61 degrees plus our variable should total to 180 degrees. X therefore would be the 180 degrees minus the 48 minus the 61. So that would be 180 degrees minus a total of 109 degrees. So X would be in fact 71 degrees. All right. Now, that's just a quick sum up of triangles measuring 180 degrees. You're familiar with that, but this will just help us to continue on in that process. Now, just like our angles, we're going to classify triangles. Particularly, you can look at two different aspects of a triangle to classify it. The first thing you can look at are their angles, and that's going to correspond to this first length section of this figure here. And then the second, of course, is by their sides, and we'll come back to that in a minute. An acute triangle has all acute angles. That means, remember, that they are between 0 and 90 degrees. Our right triangle has one right angle, and just recall that that right angle is made with that box in the corner, indicating that it is 90 degrees in measurement. And then we have the obtuse triangle that has one obtuse angle. By definition, an obtuse angle is somewhere between 90 and 180 degrees. So triangles can be classified as acute, right, or obtuse. The second way you can classify triangles is by their sides. In the illustration below, we see that the first one that we can look at is an equilateral triangle where all sides are equal. They're going to put on the same tick mark on each side to let people know that those sides are congruent in nature. The second one is an isosceles triangle where two sides are equal. The two sides with the one mark are equivalent, whereas this one down here with two is varying in amount. And then there's the scaling triangle that has no sides equal, and we can see by observing the tick marks that each side has a different number of tick marks, letting you know that each side has varying measures. So we can have equilateral, isosceles, or scaling triangles, as well as the acute, right, and obtuse. On our second page, we're going to look more closely at similar triangles. Now, similar triangles are triangles with the exact same shape, but they're not exactly the same size. A more defining way of thinking about that would be, number one, the corresponding angles have equal measure. And number two, the corresponding sides are proportional. In the next video, we're going to actually work some problems with the idea of proportionality in our mind to see what that looks like. But for now, understand that an actual similar triangle has equivalent measured corresponding angles and proportional corresponding sides. Now, if the triangle happens to be the exact same size and the exact same shape, that they coincide perfectly, that means if I took one triangle and set it overlaid it on top of the other triangle, that you would just see one triangle, then those triangles are considered to be congruent. If you look at example C, we do have one example where they are both similar and congruent. If I picked up this triangle, triangle 1, and laid it on top of triangle 2, they would match perfectly. Now, examples A and B are examples of similar triangles, and they are not congruent. Notice that the angle here matches this angle here because they both have that one tick mark, whereas this angle has 2 and this angle has 2, letting you know that those angles correspond in measure. But my sides, while proportional, are not the same length. The same is true as for example B. Now, in the next video, we're going to look at applying the knowledge from these two pages into actually working problems.